space counting principle. Down here we have some definitions. We have an experiment or a survey are both ways to gain information that cannot be predicted or know with certainty. An outcome is the result of an experiment or other situation involving uncertainty. And then the sample space is the set of all possible outcomes of a probability experiment. Okay, so example 1, the experiment is just rolling a die one time. Okay, so what are all the options you can get when you roll a die?
6.
Well, you can get a 1, a 2, a 3, a 4, a 5, or a 6, right? So can you guys look to see how they wrote the sample space? You know those fancy little brackets I told you, which are kind of a pain to draw? Well, guess what? Yeah. Whenever we write our sample space, it is supposed to be in these brackets. So they went ahead and just put 1, 2, 3, 4, 5, 6. Okay? Over here, tossing a coin. What are your only options when you flip a coin? Heads or tails. So the sample space they wrote here is just heads or tails. Okay? Good with that? Because we're going to be doing some sample spaces here in just a second. Go ahead and turn the page. Make sure you guys are following along, because if you've ever been in my Algebra 2 class previously, we didn't really write out sample spaces. So this is something a little bit new. Okay? It's easy, but it's new. Okay, it says, what is the sample space for choosing a pair of, this is supposed to say pants, from a closet with a pair of jeans, a pair of black dress pants, and a pair of khakis? Okay, so first of all, let's just choose a letter for each type. So like for the jeans, let's use the letter J. For black dress pants, we can use like a B. And then for khakis, we'll use K. So sample space, you guys ready? Watch up here. You got to make that, try your best to make that bracket, just whatever you do. It's not supposed to be a parenthesis. So try your best to draw your bracket. Don't get too hung up on it. It's really not a big deal. Okay, so aren't these 3 my only options? Either jeans, black pants, or khaki? So inside the sample space, you would just put J, comma, B, comma, K. That's it. Super simple. Okay, so then it says, what is the sample space for choosing a shirt from 2 of them if one is white and one is red? So let's use W and R. What's the sample space if we just reach in and grab a shirt? W, comma, R. Yeah, I wish there was some easy way for me to show you guys how to do those. Half the time mine don't look good either, so you just wing it. It's fine. Okay, now here's the sample space for choosing a pair of pants and a shirt. So let's just say we reach in and we grab jeans. Well, what shirt could pair up with the jeans? A white shirt, right? So we could do jeans with a white shirt, so JW. And then somebody else said red, right? So we could do jeans with a red shirt. So there are 2 options. What about the black pants? BW and BR. So that's black pants, white shirt, black pants, red shirt. And then the last one? KW and KR. Khakis with a white or khakis with a red. So you got 6 options down there. But that's just because we were pairing up pants and shirts. You guys okay with that? I bet you somewhere back several years ago when you first learned how to do something like this, you guys made some kind of little diagram. You would have done something like, I'm trying to think here. Yeah, they would have had, it wouldn't have been a T-chart. You would have had like 3 different pairs of pants down the side, and then like you would have had maybe jeans, the black, and then the khaki, and then off of each one, you would have done something like this. Like with the jeans, you could have a white or a red shirt. With the black, you would have had a white with a red, or khaki would have been white and red. And you might have even had to go further. Like what if they then said pair of shoes? You might have had 3 different pairs of shoes. So off of each of these, there'd be 3 little branches. So you just kept making these little branches off to the side. Do you think it's feasible to do this with every time? Well, no, because what if it had like 10 different pairs of pants, 5 different shirts? Like this diagram would be huge. So it's a lot easier to do something like this, or I'll show you guys in a little bit. We just end up multiplying to figure out how many different options there are. But let's do one more sample space down here. So this one says, a college offers different days to attend a class. The possible days are Tuesday and Friday. So T here, F here. Okay, so we've got 2 different days. And then on each of those days, you have 3 different class times. We have 8. Okay, so look, I'm going to call this E because the number 8 starts with the letter E. We have 1, so I'm going to put that as an O. And then 3, I'll put TH, just because we've already used T for Tuesday. So for the sample space, let's start with Tuesday classes. We could have a Tuesday class at what time? 8. We could have a Tuesday at 1, and we could have a Tuesday at 3. So far we have 3 options. And then wouldn't the same thing happen with Friday? So Friday we could have a class at 8. Friday we could have a class at 1. Or Friday we could have a class at 3. And that would be your sample space. So what I'd like you guys to notice is that when there were 2 days and 3 different times, we had a total of 6 options. Well, how do you make 6 out of 2 and 3? 2 times 3. Same thing up here. We had 3 different types of pants, 2 different shirts. We ended up with 6 options. Well, isn't that just taking 3 times 2 to get 6? Okay, so if I ever ask you how big is a sample space, most of the time it's just do the multiplication of each one. Okay? All right, next page, turn it over. Caleb, when we're done, I'll give you my copy so you can get it written down, okay? All right, so now the fundamental counting principle, this is what I was just talking about. So instead of writing out the sample space every single time, we can, or instead of doing this tree diagram, so that little thing I was drawing, that diagram, it's called a tree diagram. Instead of doing those, we can just figure out all the different ways for one event to happen, all the different ways for the second event to happen, and just multiply them together, and then we know how many total outcomes there are, or how many possibilities. So it says the fundamental counting principle is a method to determine the number of ways multiple independent events can occur. So event 1 and event 2, they list it as A sub 1 or A sub 2. But notice the total number of ways is just by taking each individual event and multiplying it by the others. Okay, so an example, if event 1 can occur in 4 ways, so we're going to write down the number 4, and then the second event can occur in 3 ways, then the total number of ways that events 1 and 2 can occur is 4 times 3, which is 12. So there would be 12 options. We just don't want to have to draw out this diagram because look, if these are the first 4 ways, then each event could happen 3 different ways with the other one. 1, 2, 3, and then I'd have to do the same thing here. And then I'd have to do the same thing here. Again, That's a lot of unnecessary work to figure out that there were 12 options when I could have just multiplied 4 times 3 and been done. So that's the counting principle, okay? So down here at the bottom, they're going to start asking you how many different ways can these events happen. So here we have 3 pairs of pants, 2 shirts, and 2 hats. What would you guys multiply together? 3 times 2 times 2. Which is what? Total of 12? 12 different outfits he could make. Like I said before, now you guys don't have to do this, but watch. Here are my 3 pairs of pants drawn out here to the side. Now watch what I do. Each pair of pants, so like this pair of pants, could match up with shirt 1 or shirt 2, right? But then each one of those branches could pair up with 2 different hats. So like this one would have hat 1, hat 2. This one would have hat 1, hat 2. That's just one pair of pants. I'd have to repeat that for the other 2, wouldn't I? Those diagrams are going to get really big. So diagrams are not always like feasible. They're not always manageable, which is why we created this counting principle in the first place. It's just a lot faster to do the multiplication, then you know how many different ways we could pair everything up. Okay? All right, go ahead and turn the page. I think you have another question like that on the next page. Oh no, they just showed you some examples here. So it says Kinsley is trying to decide what to have for lunch. They have their choice of 3 different sandwiches. So 3 sandwiches, 3 sides, and 2 types of drinks. How many different ways could they put together a different lunch? Now they went ahead and showed you that diagram, but again, do any of you really want to take the time to do all that? No, that would take forever. It would just be a lot easier to do, okay, here are my 3 sandwiches. Here's the 3 sides, and then there's the 2 drinks. 3 times 3 is 9, times 2 is 18. So we have a total of 18 different lunch options just by doing the multiplication. And then what do you guys think about this bottom one? How many different possible outcomes could you have from rolling 2 dice? Well, your first die, how many options are there? 6. And then your second die? 6. And 6 times 6? 36 different ways, different things that you could get if you were to roll 2 dice. You could roll a 1 on the first die, and then on the second one, a 1, 2, 3, 4, 5, or a 6. And then on the first die, you could do a 2, but then on the second die, 1, 2, 3, 4, 5, 6. So there's 6 options for each of the first 6 rolls or die, or whatever. So 36 total options.
That's quite a game.
Yeah, we're not gambling. But gambling is all about probability, right?
Yes.
All right, go to the last page. These are easy. You have a slot machine. Look, see, they're talking about gambling. See, this is what it is. It's all about, going to a casino and gambling, right?
Well,
It's a good thing we're all supposed to be adults here.
So what you're saying is that you should take a field trip to a casino.
Sure.
To go learn.
Yes. You guys all want to meet me down at Hollywood? We're good. But I'm not driving you guys.
I'm looking for Las Vegas.
I mean Hollywood Casino down in Lawrenceburg. I'm talking about Lawrenceburg, Indiana.
I know what you're
That's
talking
well, Anderson's got one. They're all over. Anyway, a slot machine has 5 reels, and each reel has 10 possible symbols. How many different outcomes are there for the slot machine?
50.
Okay, so hang on. It's not 5 times 10. You have to think about there are 5 different reels. So reel 1 has how many options?
10.
No. Reel 1 has 10 different symbols. Real 2 has 10 different symbols. Real 3, 10. Real 4, 10. Real 5, 10. So yeah, it was 10 to the 5th power, which is, no, you're thinking adding, dear. When you guys multiply 10 by itself, if you multiply it by 5 times, there should be 5 zeros. That's 100,000 people. I'm sorry.
If you get all
But it
that
will help
and
you.
lose all of it, bye-bye.
So there would be 100,000 different outcomes, because in that slot, it's really just one slot machine. So there are 5 reels. If you guys have never done this before, I could see why you didn't get it, but I may have been to Vegas and gambled while I was in Vegas. But there are 5 different reels within one machine, and the first one has 10 different options. So you really have 10 on each one. I knew why you said 5 times 10, because immediately I thought the same thing, but right. A lot of times this stuff is all like real world stuff. So if you've never done it, you know, it's kind of hard to like think about how it would happen. Now this one you guys could all think. So we have a die and we're going to roll it 5 times. Well, each time we roll it, how many options are there? So 6 the first time, 6 the second time, 6 the third time. It's not 6 times 5. It's 6 times itself 5 times. So 6 to the 5th. This is, yeah, that's a really, yep, 7,776. Yeah, don't ever try to do that multiplication in your head, guys. That is not 6 times 5, which is 30. That is 6 to the 5th power. When we have exponents, they get really big really fast. All right, you guys feel okay with that? Kinda-ish?
Yeah, kinda.
It's all multiplication.
What she said, look in.
Okay. I am going to give you the first practice page. Your first practice page is going to be a lot of just how many different possible outcomes. So you're going to just take a whole bunch of numbers and multiply them together. Okay? We're going to do that first. So this first lesson is done.